Good afternoon, Rich Nass, Executive Vice President with Embedded Computing Design. I'm here in the Socionext suite at CES. I'm here with Rick Fiorenzi, and he's going to show me some of these demos. We're going to talk about some of this stuff because this is cool automotive stuff.
Yeah, it is really cool, Rich, and thanks for stopping by. My name is Rick Fiorenzi. I work for Socionext. And
I said that already.
Oh, sorry. We can cut this, right? Okay, so we'll jump back in. So our first demo that we're showing here is our OmniView system. It's a 360 wraparound view system. As you can see here, we have motor reduction capabilities. So if you look here, you see distortion where the camera is shown here at the edges. And using our OmniView software, we're able to filter that distortion. You can see it's much clearer here. You don't have the same distortion.
You said just software, so it's not dependent on the hardware at all?
So our OmniView system actually runs on our graphics SoC hardware, and we'll get to that in a moment here.
Okay.
That's actually our Miranda device.
Very good.
And so here you can see we also have high-end 3D car modeling, and reflection mapping is shown. You can see here the reflections on the vehicle itself. So this car model is imported into our OmniView software using our OmniView material editor and imported. Here we're seeing that we have the capability to view underneath the vehicle. So within our OmniView software, we have algorithms which are able to estimate and project the vehicle path and compensate for the actual viewing surface under the vehicle. So it takes frames that were previously recorded, and it also inputs vehicle steering position as well as speed. Here's another demo that I'd like to show you. The way the OmniView system works is it takes the 4 cameras and it stitches each camera, so it creates a composite image. That composite image is projected onto a 3D surface.
Is 4 cameras always enough? Is that the optimal number?
So we can actually support up to, good question, Rich. So actually we can support up to 6 cameras. So based on the size of the vehicle. So for most SUVs and large consumer grade vehicles, 4 cameras is typically enough. When you get into larger larger trucks and commercial vehicles, you may require additional cameras. So with our Miranda hardware, we're able to support up to 6 cameras.
Very good.
And so as you see here, we're dynamically changing the viewing perspective to anywhere within the 3D 360 degree field of view. So our OmniView system has been into production for over 10 years, and we're continuing to improve and enhance the image quality, and the stitching is best in class as well.
Awesome. So Rick, what are we showing here?
So Rich, this is our Miranda cluster and DMS driver monitoring system, hybrid solution. It features our SC1810X family of graphics SoC products. Our Miranda is the same hardware device that is used in our OmniView demo that we just, our 360 wraparound view. And it features 6 times camera input. It can also drive up to 3 times full HD displays simultaneously with up to 8 layers on each display. So you can see here we have a car model that's being rotated 360. That's 1 layer. We have a speedometer here and an RPM gauge. Those are both on separate
So
layers.
this would actually be embedded into the vehicle?
So yes, so this would be embedded into the head unit. So typically in a domain computing type architecture for HMI systems consisting of an instrument cluster as well as a information center stack, you'd have a main graphics SoC simultaneously driving both displays. So I also want to show you our driver monitoring system, which is featured here. So you can see this camera here is facing me, and you can see as I turn my head, you can see the vectors are tracking my eyes. If I look away for an extended period,
That's eerie that it's tracking your
yeah,
eyes.
isn't that eerie? You can see this meter here is this gauge
that's cool.
indicating that I'm distracted severely at this point, right? So when I turn back, and now it goes back to normal.
Yeah, but how do you do drowsiness?
And so for drowsiness, if I'm to actually close my eyes and yawn,
That would be drowsy. You're severely drowsy.
you can see that I'm severely drowsy.
Severely
at that point.
drowsy.
Yeah, and definitely don't want to be on the road when you're in that condition.
Wow,
I think
that's-
we've all experienced
That's
that once
amazing.
or twice. So this is, in a normal application, you're capable of detecting drowsiness and then alerting the driver to make sure that he's aware of the situation. So all of these features and functions, including our 360 wraparound system, our drive and monitoring system, and our ability to drive the graphics and do the rendering to multiple displays, is all part of our graphics SoC family Miranda.
Okay, Rick, it looks like we've just entered the Batmobile. What are we looking at here?
Okay, Rich, let me explain. So this is our remote display concept demo. It's featuring our Indigo graphics display controller. So our Indigo graphics display controller resides on each of the displays shown here. So here we have an instrument cluster. This is a 1920 by 1080 full HD.
So is this a separate controller for each of the displays, or this one controller running all three displays?
So in this scenario, we have one main controller here in the head unit.
Okay.
And it's sending the video and data
Okay.
to each individual display.
Got it.
So on the actual show here, for example, on the cluster, the Indigo is mounted behind the display, and it's receiving the data in the video, and then there's bidirectional communication back to the head unit. So in case there's loss of signal or a mismatch, we lose the main video signal in this example, we're still able to show the safety critical features and telltales and warning and cautions. We also have a sound generator built into the Indigo device, which you can see here is actually making the hazard sounds.
So basically, if you crash, you won't crash.
Exactly. Your system won't crash. You'll still have the information that's critical.
That was my attempt at comedy.
Okay. Thanks, Rich. I have to take some lessons from you. And so you can see here we're still getting information related to the speed. This information is coming through the data link. So we don't have our main video, but we still have communication through the back channel. Our Indigo device can support high bandwidth back channel up to 100 megabits per second. It's Ethernet based. So, and this one here, we're driving a full HD center stack. So here we're showing a backup camera, and we have an embedded frame counter. So the Indigo is capable of checking on a frame-by-frame basis a reference. And if the reference has a mismatch, it can trigger a caution signal directly onto the camera. If there's a mismatch that's triggered, it can put a caution or a warning signal directly onto the display. It can also send that information back to the back channel of the head unit for further processing. So if there was, say, an actual camera freeze, the head unit might tell it to display just a blank surface here instead of a caution, but you have that option as well. Let me show one more. We have, on our Indigo, we have support multiple peripherals. We also have high speed, high accuracy ADCs. And in this case, we're able to collect data from a touch controller.
It is warm in here. Can you crank up the air a little bit?
Yeah, let me crank that up for you. How's that?
That's great.
Oh, we're going wrong way. There you go. Let me turn up the fan here for you.
Thank you.
Yeah, no problem. So the last display here is a passenger information display. It's showing the capability of our Indigo device to drive 3K 2880 by 1080 resolution to this display at 60 frames per second. So essentially our Apex link and our pipeline through our Indigo is capable of very high bandwidth. We also support VESA decompression as well, so we can support even higher bandwidth with compressed video.
So this family, how long has this been around?
So the Indigo has been in production for over 10 years.
Okay.
And now we're in our third generation Indigo series. So we have a lot of road proven experience, and it's
No pun intended.
No pun intended, exactly.
Very good. Thanks, Rick.
Thank you. Appreciate it, Rich.